So in this video, our goal is to integrate the function right here. Before we start integrating, we note that here we have a plus sign. That means that we can rewrite our integral as follows. We have the integral of minus x e to the minus 1/2 x squared plus the integral of dx plus the integral of the square root of x dx. So what we can now do is first we just integrate this and then we integrate this separately. So now we can write that down here. We have the integral of minus x e to the 1/2 x squared and all minus dx. And now our approach will be that we will use clever u-substitution. Our main problem is that we have this minus x here and we would like to have this part at the top of here somehow simpler. So we will just go on and try to differentiate this right here, because if we differentiate it, we have just an x, we have an x right here, and maybe they will cancel out. So wherever u is equal to minus 1/2 x squared. If we take the derivative du to the x, this is equal to, now we can differentiate this, the 2 comes down, so we have minus x. Now we need to reformulate this in terms of dx, so we just multiply by dx and divide by minus x. So dx is equal to du over minus x. Now we can take our integral into the u world. So you have the integral of minus x e to the u du divided by minus x. What we see now is our minus x and minus x, they cancel each other out, so we are left with an integral which is way simpler. It's just e to the u du. We know how to integrate this. This is just simply e to the u plus c. Now don't forget to go back to the x word, so we need to substitute back. So u is equal to minus 1/2 x squared. This means our integral evaluates to e to the minus 1/2 x squared plus c. This is the first part. But don't forget that we also have the square root of x dx. So now what we can do is just integrate square root of x dx. We can rewrite the square root of x as follows. This is equal to x to the 1/2 dx. If you don't know how this works, quick interlude right here. If we have the nth root of x to the m, this is equal to x to the power of m divided by n. This is sometimes quite useful if you need to integrate something. Now we can just use simple integration. This would be equal to x to the 1/2 plus 1 divided by 1/2 plus 1 plus c, and 1/2 plus 1 is 3 over 2. So we have x to the 3 over 2 divided by 3 over 2, which is equal to 2x to the power of 2 over 3 divided by 3 plus k, which is just our constant. Now we can put those two integrals together, this right here and this one right here. So we get that our initial integral is e to the power of minus 1/2 x squared plus 2x divided by 3 over 2 plus c. We can just, this constant and this constant, we just rename it and just use the constant c. It doesn't really matter. We could also write c plus k, but we just put them together into c. This is our final solution. Don't forget to like this video and subscribe to this channel so that you don't miss any video.